in yesterday's class. See, we studied about Einstein's photoelectric effect. Okay, how experimental study of photoelectric effect, what he has done. So there are 4 graphs. So and 4 definitions also. Number 1, it is about what is photoelectric effect when a light of certain frequency is made to incident on a metal, then what happens, or a shining surface, then electrons are ejected out. That is photoelectric effect. The material which is the material or the which is used for this purpose is known as photoelectric photosensitive surface or photoelectric material. And the electrons which are coming out are known as photoelectrons. This is the first definition. The second one is what is work function. Work function means where light of it is the minimum amount of energy required to bring the electron to the surface of the metal. How much amount of energy is required to bring the electron to the surface of the metal? That is known as work function. Next is threshold frequency. What is threshold frequency? It is the minimum frequency for which the electrons are ejected out or emitted out of the surface. That is threshold frequency. Fourth definition, that is stopping potential. The minimum potential of anode for which no photoelectric emission takes place, or that is known as photoelectric effect. Okay, 1 second. Now, so that was about the photoelectric effect. Okay, so the 4 definitions. Number 1, what is photoelectric effect? What is work function? What is threshold frequency? One is stopping potential. These 4 are very, very important. Next one, there are 4 graphs again. First is what? Photo intensity of incident radiation versus photocurrent. So as that was what? First one, if you see, it was I'll draw the first figure here. The first figure, what he's saying, that is intensity. This is intensity. Intensity versus photocurrent. Okay. Intensity versus photocurrent. So what happens as the intensity increases, photoelectrons also increases. Means what? First, as I told you, it depends upon the frequency of the incident radiation. Okay. First of all, 1 second. Now, so here, the photo as the intensity of light increases, the photocurrent also increases. Means first of all, as I told you, like suppose maybe for red color light or an orange color light, as the intensity is increasing. As the intensity is increasing, nothing is going to happen. Okay. Now, but with yellow color light, as the intensity increases, one second. Now see here, now as I told you, suppose for red color light, even though if you are increasing the intensity of radiation, then also no photoelectrons are emitted. For orange color light also, suppose light incidents on the metallic surface. No electrons are ejected out in this case also. But when it became yellow color light, as the intensity of radiation increases, means intensity means like this. As the intensity increases, more and more electrons start coming out. Understood? More and more electrons start coming out. So that is what he's saying in the first graph. The second graph is about what? The second graph, it says about, okay, the second graph, it says about, now this is V0. V0 is the stopping potential. And this is 0, and this is saturation current. This is saturation current. Okay. Can you keep the phones here for some? Both here.
I have very less.
Okay, keep it here. Now suppose for the second one, what he is saying, this is the intensity I1. I have taken yellow color light example, and this is V0. V0 is the stopping potential. Now I increase the intensity. Now what happens? The anode potential, I'm making it like +5, +4, +2, +1, 0, then -1, -2. So when it is 0, then also it is receiving some electrons. But what happens as you are decreasing it, it becomes 0. So whatever it is, whatever be the intensity of light, whatever be the intensity of intensity of light, that is I2, and this is I3. Whatever may be the intensity of the light, then what happens here? Here we have photocurrent. Okay, this is photocurrent. Then and this is the potential. Okay, collector potential. Keep the phone here, I said. Both of you. Now, so here we have plate potential. Okay, this is plate potential, collector plate potential. Okay, so this is said to be retarding potential or stopping potential. Retarding potential, or we say stopping potential, or we say cutoff potential. These are the three different names. Same thing can be asked in different ways. Okay, one is retarding potential, one is stopping potential, and one is cutoff potential. Okay, so these are the three values. Okay, V0. Third graph. This is the fourth graph. Third graph. So quickly we'll go to the particle nature. That is Einstein's photoelectric equation. We will do it, and then we can go for particle nature of electron or light. Then last one is wave nature of matter. Only these three topics, small topics, are pending. Only these three small topics are pending. Okay. Now, first graph, second graph, this is fourth graph, and this is third graph. Third graph is like suppose this is origin. Again, this is a plate potential. Okay, collector plate potential. Collector plate potential. So so this one is what retarding potential, and this one is photocurrent. This is photocurrent. Now what happens here? So here this is the first one. For the same intensity of light, I am taking only one intensity but three different colors. Maybe this is the first one, the second one is here, and the third one is here. So this is what? This is new 1, new 2, new 3. New 1, new 2, new 3. So that is intensity. I is the intensity. This is collector plate potential. So here we have one is maybe yellow color light, this is green color light, and this is blue color light, but with the same intensity. Okay, keep this in the mind, same intensity. Now what I am doing, I'm again decreasing the potential of the anode. So at a particular point, it starts rejecting the electrons. So that is what this is said to be V01 minus V01 minus V02 minus V02. Okay, so this is about the three different values. And the fourth graph here, frequency of incident radiation versus stopping potential. So as the stopping potential is means what? As the stopping potential is decreasing. Okay, as the stopping potential is decreasing, is frequency of incident radiation decreases, stopping potential also decreases. As the frequency of the incident radiation means what, or like it is violet, then blue, then green, then yellow. Okay, like that we are taking. So I will take it here once again. This point is violet. Maybe this is blue. Maybe this is green. Maybe this is yellow. Okay. So violet, blue, green, and yellow. So maybe at that particular color it stops. Okay. So as the frequency, because this is decreasing frequency, as the frequency is decreasing, stopping potential also decreases. So these are about the 4 different graphs. Still, if you have any doubt, please ask me. Still, if you have any doubt, ask me. I'll be conducting a test, sir. This from next week onwards. Next week onwards, it will be there, and those marks will be published directly into the group. If you don't write, that also I will write. Now, no more. No, until now, I was very liberal. Okay, very liberal. We will start.
So evening or morning?
Tomorrow morning 8 to 9. Morning 8 to 9:30, or maybe 10 also. 2 hours maybe. Because I need to complete the
class from 9 to 12.
I said no compulsion. Anyways, I'm recording the classes. What more a teacher can do? Is it? Okay. Now, next one here.
Yeah.
The graph. What is we'll discuss about the 4 graphs. Okay, the 4 graphs, what they are saying. Number 1, it says the stopping potential varies linearly with the frequency of the incident radiation for a given photoelectric material. The first one here. See here. The first about this graph, the first point, it says that the stopping potential varies linearly. See here. Like I have taken 4 colors: violet, blue, green, and yellow. Maybe yellow is the starting point out of FGR colors. I have, because this we know. I can go in infrared and UV also, but infrared UV it is very difficult to understand. Clear? Maybe for a particular material, I have taken something like that. Red and orange is not working out. For yellow, it started working out. So maybe when this is yellow is the threshold frequency. Okay. Then what happened? The color is increased. So when I increase the frequency, the stopping potential is also increasing. Again, I increase the frequency, stopping potential is increasing in that way. Is that clear? So we have yellow, green, blue, and then violet. Okay. So these are the 4 different colors. Is that clear? Now, so the same thing, maybe it is, maybe here, it may be some other color. Okay. Maybe it is starting with green here. Example, this may be green, this may be blue, and this may be violet, something like that. Understood now? So from this graph is having a significance because from this graph, we found out the Planck's constant. From this graph, we found out the Planck's constant. For that reason, the graph is important. Planck's constant, you remember, right? 6.624. What is that? 6. Yeah. You don't know. What about it? 8 people we have here. It is in chemistry, first lesson. Atomic structure.
Chemistry.
So E2 minus E1 is equal to H. You learned this in first chapter atomic structure lesson.
First time you learned it?
In atomic structure lesson, it is there.
Atomic structure chapter.
Anyways, this is the first point. The second point is there exists. Okay. So he says there exists a certain minimum cutoff frequency for which the stopping potential is 0. There is a minimum cutoff frequency. Here, this is the minimum cutoff frequency for which the stopping potential is 0. Here, see, the stopping potential is 0 for this particular value. Is that clear? This is the second point. Third point, the maximum kinetic energy of the photoelectron varies linearly with the frequency of the incident radiation, but independent of the intensity. Now it says the minimum kinetic energy of the photoelectron varies linearly with the frequency of incident radiation. Okay. Next one is for a frequency nu of incident radiation lower than the cutoff frequency, no photoelectric emission will take place. Below this frequency, no photoelectric emission will take place. This is the frequency. Is that clear? So these are the 4 different graphs. These 4 graphs are very, very important. Definitely, you drew this one. Okay, draw this fast. Then we will go to the next 3 topics are pending. I'll try to finish off now. Okay. See, in this situation, they can give a graph and ask the question, or they can ask just like stopping potential. Draw the variation of stopping potential versus frequency of incident radiation. They can ask like that, or photocurrent versus collector plate potential. Such type of question can be asked, and they will ask the behavior of that. So maybe not they not give the graph. If they give the graph, it is easy. Okay. No, so second one, very good. So now energy quantum of radiation. So what happened here is, see, he says that now this is the incident. This is the photosensitive surface. Okay, this is a photosensitive surface. Now we have like this is the incident radiation. Now this is the electron. This is the kinetic energy of electron. Electron is coming out. This is h nu, and this is said to be phi 0. Is that clear? Here, E is equal to h nu is energy of incident radiation. Energy of incident radiation. Now here, K is the kinetic energy of electron. And phi is what? Work function. Phi 0 is said to be work function. So these are the 3 situations. So here, what is the formula now? H nu we are writing. See, we are writing here h nu is equal to phi 0 plus half mv square. That is kinetic energy. Phi 0 plus kinetic energy, or K max, maximum kinetic energy. Now, how will we calculate maximum kinetic energy? Maximum kinetic energy equal to what? H nu plus minus phi 0. Means when we incident this light, any radiation, what happens? Some amount of energy is required to bring the electron from ground state to the higher level. From ground to the higher level. That is phi 0 work function. It is on the surface of the metal. Now, with the remaining energy, it will fly. So that is having kinetic energy. So K max is equal to h nu minus phi naught. Now, if there are now cases are there here in this. Can I erase this part?
Yeah.
Okay. Sorry.
I drew it enough. You do your.
So most probably today I'll finish this lesson, and tomorrow I'll be starting with atomic physics, atoms, then nuclear physics. Maybe within 2 or 3 days we can finish off. These are small lessons, my small. What will take will not.
When did we start this?
Day before study.
Oh, sorry, on site after.
Yeah.
What is the chapter name?
Now,
Dual nature of
wow.
Matter indicator.
If H nu
You
is
were
equal to,
asking chapter name. Don't talk.
okay, if H nu is greater than pi 0, what is the meaning of this? If the energy of the incident radiation is greater than the work function, what will happen? With the remaining energy, the electron will fly. Is that or emitted from the surface of the metal? Okay. See, if H nu is greater than the work function, means the incident energy is greater than the work function. With the remaining energy, it will get emitted. The electron will get emitted from the surface of the metal. So here, what will happen now? We also know that phi 0 is equal to what? Phi 0 is equal to H nu 0. Remember this one. What is nu 0 here? What is nu 0, sir?
Energy.
What is nu 0? What is nu 0?
Permittivity of free space.
Nu 0 is said, man, here.
It's not epsilon 0.
Nu 0.
the brother.
What is nu
It's
0?
around.
Now, nu 0 is what?
It's around.
Nu 0 is threshold frequency. Nu 0 is threshold
Yeah.
frequency.
It's around.
Okay. And
Yes, sir.
what is V0? What is V0, sir?
V0, redefined formula for V0.
What is V0? Yes, anyone can tell. Ismail Arham.
You
What
say
is
no?
V0?
Sir, is saying permittivity of free space.
That is the situation.
Stopping frequency. Sorry, stopping
We got this
property.
all
Sorry,
because-
stopping potential.
With knowledge. Only I can pray for you. That is my situation.
That's the future of this world.
Sir, after all the questions are done, can we start from the first?
Revision, sir, revision.
So not revision.
Then also of no use. And why? Because there is no consistency of people.
Sir,
This is what I have seen.
you take revision, will be consistent.
Who's the problem?
You need to have a consistent approach. That is very, very important.
That
To,
will have.
to gain any success, whether it is in sports or whether it is in education, any sector, whether in gaming also, you need to have a consistency. That will-
But a board exam, are giving those up.
No, I'm telling you, now December is gone, forget about it, because January 5th onward, I think the timetable is uploaded. Right? Timetable is uploaded.
Yeah, yeah.
Sorry,
Pre-board,
it's okay.
pre-board, all three with him.
All three
Pre-board and
are-
December examples. You want?
No, actually, 2 days back I gave to Renu to upload.
Yes, sir, all three.
Hold on.
You know, uploaded also.
She uploaded. I told you I was waiting for signature. So it got uploaded and
So that is an auditorium now.
Pre-board.
yeah, that we didn't decide, but
Sir,
it will
sir,
be mostly in
auditorium.
auditorium. So 20,
Mat ka hai.
see, 5th,
Yeah.
listen, 5th onwards it is starting. 5th of
Yeah.
Jan it is starting and goes up to 23rd, I think.
Yeah,
Okay,
yeah.
with a gap in between. And from 23rd onwards, maybe most 99% practical exams will start immediately after that. And
So board
Pura-
practical.
more practical exams will start immediately after that. Maybe sometimes we need to, I think what is my intention, intuition, maybe 23rd, that exam also may get preponed. Or then it may get cancelled also. Because maybe 21st onwards exams will start. That is my thinking. But ma'am said it, no, it won't be like that. 25th, it will be like that something. Because the dates are given from Indian consulate. So waiting for that. So most probably you don't have breathing time, I'm telling you. So if any practical record or a project is pending, try to finish off in this December. You don't have any breathing time also.
Sir, I haven't practiced one practical in physics. कैसे होगा?
Then you have to practice. Or in between come and practice.
कैसे? He doesn't allow. He doesn't help
Any-
us.
So we will see later on about. We will take it. See. Yeah, listen. This is threshold frequency and stopping potential. These two are the values. Then we have here phi is equal to what? Here we have V0. Nu 0 is equal. We can also calculate nu 0. So how to calculate nu 0? Threshold frequency. So phi 0 by h. Just substitute. You will get the answer. This is the first one. Then we also know that kinetic energy, maximum kinetic energy. We also saw that maximum kinetic energy is equal to what? E into V0. Why E into V0? See, we have the formula. V is equal to W by Q. Is it not? This we studied in second chapter. E is equal to, I told you, keep the phone here, both of you. I'm not joking. Here I said. Now, so V E is equal to, so what happens? W is equal to what? W is equal to V. So what happens here? W is equal to kinetic energy. V is the potential, Q is the charge. So that is how we calculated the maximum kinetic energy. Now we are going to substitute in this equation. This is our primary equation. Which one? Where is that? Yeah, this is our primary equation. We are going to substitute all these values here. So now H
So
nu
I
is
have to learn the value of H.
yeah, you have to learn all the constants. You have to learn permeability, permittivity, permeability. Now, actions speak louder than words,
Handwriting is not mine.
right?
It is.
Right.
That's not
I am
my-
listening there.
Yeah.
He
Now-
wrote grow Monday.
So
I don't know.
here we have so therefore we have H nu is equal to what? 50. H nu is equal to 50 plus E into V0. Okay. H nu is equal to 50 plus E into V0. Okay. So E into V0 is equal to how much? E into V0 is equal to H nu minus 50. This is the value. E into V0 equal to H nu minus 50. So where nu is greater than nu 0? Where nu is greater than nu 0. Okay, the value of nu is greater than or equal to nu 0. So I'm going to write this. These are all important because with these equations only there is no derivation at all. There is no such thing like derivation. These are all the equations only. So that's what he said Einstein's photoelectric equation. There is no derivation for this. So that is energy quantum of radiation. We started. Let me finish off this. I'll explain once again. So we got this equation. Now we are writing here, cross multiply this. V0 is equal to how much? V0 is equal to H nu by E minus 50 by E. So V0 is equal to H by E into nu minus 50 by E. This is in the form of, y is equal to mx plus c. See, it is in the form of y is equal to mx plus c. What is this? Y is equal to mx plus c. Equation of a
Slope. Oh, sorry, straight line.
Oh,
Straight
equation
line.
of a straight line.
Straight line. Straight line.
Equation of a straight line. So y is equal to mx plus. What is m here then? What is m and c here?
so C is a constant.
C is a constant or said to be y intercept.